Stanford University.
Okay, well, welcome then to Lecture 14 of Stanford CS 193P, spring of 2016. Today we have two topics. One is I'm going to continue the dynamic animation we talked about in the last lecture in slides with a big old demo, okay, that really shows a lot of dynamic animation in action, and homework assignment 6 is all about dynamic animation, so be preparing you for that. And then I'm going to do a new topic. I'd said last time it was probably going to be alerts, but actually I'm going to do core motion now, okay? And I'm going to do some slides on core motion, and then I'll also do a demo. Hopefully I'll have enough time to do all that today. All right? Okay, so let's dive right into this demo. It's called Drop It. It's basically as if I were going to go write a Tetris app, okay, with little falling blocks that you put in place, and then you complete a row, and the row would disappear, and then more blocks would come down. Kind of like that, but this is a demo. We're starting from scratch, so we're just going to have little individual blocks come down, and when they all make a row, then it'll disappear. So we're not going to do the L-shaped and T-shaped blocks from Tetris. We're just going to do squares only. Okay, so we're kind of like we're getting started on Tetris. So I'm not calling it Tetris because doesn't look enough like Tetris. For that, I'll call it Drop It, because we're going to be dropping little squares. Okay, so I'm going to create a new project here. It's an iOS application, as always, single view. I'm going to call it Drop It. Okay, we don't need core data. Okay, it can be a universal app. I don't see any reason why this app wouldn't be universal, as you'll see. Okay, so here's Drop It. We'll put it where we always put everything. Here it is. Now, what's interesting about Drop It is I'm going to build the entire user interface in code. So my storyboard, all it's going to have is one custom view. Okay? And then I'm going to do all in code, because we're going to use the animator. We're going to have a lot of animated views going on. That's what's going to be the entire UI. So I don't really want this generic view controller here, so I'm just going to take this generic view controller and delete it. Okay? Move it to the trash. And then I'm going to do the thing we always do here, where we take these little guys and move them off into supporting files, because we don't need to do anything supporting files, because we don't really need to do anything with them. And so I'm going to, right off the bat, create a custom view controller for this view controller that I have here in my storyboard. And I'm also going to create a custom UI view. And that UI view is really where the logic of my game is. You can almost think of it as like a game view, right? And I could actually put this view anywhere in any UI, and it would play this game, this Tetris-like game we're going to call Drop It. So let's go ahead and create those two classes, the UI view controller and the UI view. So here's the UI view. We'll call it Drop It view. Okay, it's going to be the Drop It view. We'll put it in the same place here, not in supporting files. I'm going to put it where all the rest of the things are. Hey, there's my Drop It view. My Drop It view actually is not going to implement DrawRect. Okay, it's going to implement its entire existence with subviews. Okay, so it's not even going to have a DrawRect in my Drop It view. And then I also need my controller. Okay, so same thing here, but this is going to be UI view controller, and I'm going to call it my Drop It view controller. Okay, same place. Okay, here's my Drop It view controller. I'm going to clear all this stuff out. All right. Now that I have these two classes, I'm going to make my storyboard just make it so that this view controller that I have, I'm going to go to the identity inspector over here, and instead of having it be just plain view controller, it's going to be a Drop It view controller. Okay? And same thing inside here, I'm just going to put a view, a generic UI view. So let's scroll down and find that, where that is. There is that, right here it is. Okay, generic UI view I'm going to put in here, and I'm going to change its identity to be Drop It view. Okay? Now I'm going to use constraints here to have this fill my entire view controller here. So I'm going to put it right there, use the blue lines to put it on the edges. Then we'll go down to here. Oops. Down to here, and we'll say reset to suggested constraints. I always like to look in the size inspector, make sure it did what I wanted, which it looks like it did. Okay? So I've got this Drop It view in here inside my Drop It view controller. I'm also going to create an outlet from one to the other. Okay, so I'm just going to control drag into my Drop It view controller to create this view. I'm going to call it my game view. You can see that it's of type Drop It view, which is good. That's what I want. Okay, so I've got my game view. So this is my basic setup of my game. All right, and really all the controller's going to do, maybe set up some gestures, possibly a little bit of view controller lifecycle here and there, but most of the logic is going to be inside this drop it view class. Okay, so let's make our screen bigger here. All right, so let's dive right into this drop it view. I'm going to have my drop it view start by being able to put a little square, okay, like these things that are going to fall down like Tetris, except for there's going to be squares. I'm going to have a little method that puts a square there. Okay, so I'm going to need a little bit of some private data here. How about private let drops per row equal 10. So this is how many of these little drops that are going to fall down will fit across the top of my view. They're falling down from the top, right? So this is how many. So 10 across is a good number, I think. And then I'm going to have a drop size, okay, which is going to be a CG size. That's going to be the size of each of the little things that falls down. And I'm going to have that be calculated, okay? And I'm going to calculate it by letting the size, have it be square, and we'll have the size be the width, whatever our width is at the time we asked this, divided by the number of drops per row. All right? So I'm going to have the size be so they'll fit across the width of our view. Now, by the way, our app might rotate, and this width might change, so the drops might actually change as we rotate and stuff, but we could decide if that's what we wanted or not, but this is perfectly fine. So now I'm just going to create a CG size here whose width is the size and whose height is the size. So it's square, basically. So this is going to be the size of a drop, a square that fits 10 across the top. Now I'm going to have a function called addDrop that just adds one of these things, one of these little squares that's going to fall down from the top to the view. So of course we need the size of this drop to be put into a frame. So I'm going to create a frame which is CG rect. The origin of the frame is going to be at CG point 0 to start. I'm going to put it in the upper left-hand corner, and then I'm going to move it over into one of the slots along the top. And the size, of course, is the drop size. So let's do that frame movement. So I'm going to move the origin.x equal to, and really what I want here is a random float, okay, somewhere between 0 and the drops per row. Okay, that's pretty much where I put it. So if I like to sometimes if I want to have a function on CG float called random, I'll actually make extensions. And so I've made some extensions. Here they are right here, UIKit extensions.swift, which I'm going to copy in here. And these extensions are just some convenient things that I've created that are going to help my demo go quicker. So you can see I've created this random function on CG float. I've created a random function on UI color, which gives me a random color. Kind of fun, right? And then some CG rect things here, other stuff. So you can look through this later at your leisure. But I'm going to use one of them here, which is this CG float.random that takes an int, drops per row. Okay, and so that's going to create a random float between 0 and drops per row. And then I'm going to multiply that times our drop size width. So I've picked a spot across the top. A random spot across the top there. So now I'm going to create the drop. I'm just going to say it's a UI view, a generic UI view, whose frame is frame. Okay, this frame I just created right here. So I got the drop. And let's set the drop's background color to a random color, equals UI color.random. Okay, that's one of my UIKit extensions that I created there. And then we're going to add subview the drop. Okay, just put it on screen. Okay, makes sense? Now I'm going to cause this addDrop to happen whenever I tap. So I'm going to put a gesture recognizer back here in my controller. A lot of this, by the way, is review, hopefully, for you guys. But I'm going to, when my game view gets set here, I'm going to add a gesture recognizer. So I'm just going to say game view, add gesture recognizer. It's going to be a tap, UI tap gesture recognizer. The target is going to be myself. And the action will be, let's say, a selector. We'll call it addDrop. This one has an argument, okay, because it's a gesture recognizer. Okay, so we'll just do that. And then I'm going to have a little func here, addDrop, which takes a recognizer, which is a UI tap gesture recognizer. What did I do here that's no good? That's good. Okay, we fix that. All right, so when we have a tap gesture, we basically want to check to see if the recognizer state has moved to ended. If it does, then there was a tap. And now I'm just going to tell my game view, okay, go ahead and add one of those drops. Okay, everybody see what I did there? Just create a little tap gesture, just going to call this method add drop over in my drop it view. Okay, so let's switch over to the drop it view again. It's going to cause this add drop to happen right here. All right, so let's go ahead and run. We'll run on iPhone 6 here. So now when we tap, it should put a random colored block along the top. Okay, so tap, there it is, a green one, purple. Okay, excellent. See, as I click, it puts more along the top. Now, of course, we want these things to fall down. Okay, we want them to fall down to the bottom, and we know how to do that with Dynamic Animator. We're just going to create a gravity behavior. Okay, and the default gravity behavior is downward gravity at 1,000 points per second squared. So that's exactly what we want. So that's all we need to do is create a gravity behavior and add it to an animator. So let's do that. Up here, I'm going to create a private let gravity equal a UI gravity behavior. Okay, and of course, I also need an animator. So I'm going to say private let animator, which is going to be a UI dynamic animator. And actually, let's just create one right here, a UI dynamic animator. And we know that when we create a dynamic animator that's going to be animating views, we want to say what the reference view is, okay, which in this case is self. Okay, where a drop it view is a view, so reference view is self. Now, oh, we have an error here. Anyone know what the problem here is? Okay, what are we doing right here? Initializing, right? We're initializing. Can we refer to self when we're initializing? No, because self is not fully initialized yet. So we can get around this, though, with our favorite lazy var. Okay? So now it's not going to initialize this until someone asks for the animator, and that's not going to happen until we're fully initialized. So we're winning. Right? Okay, so we got that. Now I'm going to actually make a public var here called animating, which is going to be a bool. And we'll start it out equal to false. And this is going to be basically how we turn on and off the animating. If you say animate equals true, then we're going to have these blocks animating. If you say animate equals false, they'll stop animating. Okay, so it's kind of like the on-off switch for our drop it view. So what are we going to do here? I'm going to say if someone sets this, then if they set it to true, okay, then I'm going to animate this, which all I need to do to animate is to take the animator and add the behavior of the gravity. Okay, as soon as you add the behavior to the animator, it's going to start animating it. Okay, and similarly, if they turn animating off, then I'm just going to do the opposite. I'm going to remove that gravity behavior. Okay, and that's going to stop it animating. Okay, got that? Now while I am here, let's go ahead and set this. We're going to set this in our controller. So I'm going to go back to our controller right here. And let's do this in our view controller lifecycle. So how about in view did appear? As soon as view did appear happens, let's go ahead and set this game views animating to true. Okay, so that's going to start it animating. And similarly, on view will disappear, we will turn the animation off because we really don't want this thing animating while we're not even on screen. So it's a good place to turn it on and off. Everyone understand that? Okay. If you don't understand anything I'm saying, feel free to stop me. Okay. All right. So that turns it on and off. We got this thing going. The only thing we need to do here is this behavior. Currently, there are no items that have been added to this behavior. So nothing. This gravity is not affecting anything. So of course, every time we add a drop down here, we're going to want to add it to the behavior. Gravity add item this drop. Okay, and that makes gravity start affecting that drop. Everybody got all that? So we've seen all the steps now of dynamic animation making it work, right? We created the animator, we created our behavior, we added the behavior to the animator, and then we added items that we want affected by that behavior to the behavior. All right, so let's go see this work. Okay, so here we go. Let's run. Let's try tap. Let's use our tap gesture here. And look, they're falling down. See, they all fall. We can kind of click as many as we want, and they all fall. Now, of course, the problem with this, as from a Tetris point of view, is they just fall off the bottom. And we really want them to hit the bottom and stop, right? And pile up so that they'll make rows, and we can clear the rows out, right? So the next thing we're going to do is put a boundary, and we're going to put the boundary all the way around this thing, okay? It's a real simple way to create a collision boundary all the way around this reference view right here. So let's do that. All right, go back over here. So to do that, we need to create another behavior like the gravity behavior. And this one is I'm going to call my collider, and it's going to be a UI collision behavior. Okay? Now I could just do that. The problem is I need to configure this because I want to tell this collision behavior, make the bounds of the reference view be a boundary. So I'm going to create this in a kind of a cool way. Hopefully you remember that you can do this, which is that I'm going to do it with a closure. I'm going to initialize this variable by executing this closure right here. Okay, everyone remember that we can do that? So I'm going to create a little local variable here. It happens to be called the same thing, but wouldn't have to be called the same thing as the variable. This is just a local inside this closure. And I'm going to set the collider to translate reference bounds into boundary equals true. And if you do that, the UI collision behavior will automatically have the bounds of the reference view be a collision boundary. Then we'll return the collider here. Okay, make sense? Now this collider, just like the gravity, if you do this when you make a closure, don't forget that you have to explicitly type the var here, and that's because it wants to be able to check to make sure the return value here matches what you want it to assign to here. Okay, so just like we added the gravity behavior, we're going to have to add the collider as well. So just like here's the gravity, we're going to do collider. And same thing, obviously, when we stop animating, we want to remove the collider. Okay, and also down here, where we want gravity to work on the drops, we also want the collider to work on the drops. If I didn't do this, then the drops would still keep falling off the end because the collider would not be behaving, the collider behavior would not apply to them. Okay, we got that? So let's see if that works. All right, here we go, drop, and oh, sure enough, look, they're piling up. And here, oh no, oh, well, we're never going to get a completed row there. How are we going to do that? All right, well, we obviously need more behaviors here than we have. And the next behavior we want to do is a behavior that makes it so that those things don't rotate like that. Okay, they don't tip over and start piling on top of each other right there. We want them to stay in nice rows. So we want to turn rotation off. And to do that, we need a dynamic item behavior, which I talked about in lecture. But it's starting to get to a point where I've kind of got a lot of messy code because I'm adding behavior, another one. I'm going to add, remove, add item. So I'm going to do the thing I talked about in lecture where I create a new behavior, which is all these other behaviors combined, like a composite behavior. Okay, so let's go file new up here. Okay, it's a CocoaTouch class. This one is a subclass of UI dynamic behavior. Okay, and I'm going to call this the falling object behavior. Okay, because that's what it is, it's a thing falling down, falling object behavior. Okay, I don't want to put it in the top level, drop it here. I want to put it down here where all the rest of my classes are. I notice some of you sometimes make that mistake in your homework. Really nice to keep your files together there. Okay, so here's my falling object behavior. It's a UI dynamic behavior. And I'm just going to go and copy and paste those two behaviors I already have, these two guys right here, out of here and over into here. Okay, because I want this falling object behavior to have these two behaviors right here. The other thing we do when we create a dynamic behavior subclass is we're obviously going to have an init. So I'm going to override the init that comes with UI dynamic behavior, call super init, okay, because I need to do that on the rules of init. We haven't talked a lot about inits, by the way. Again, hopefully you haven't needed them too much in your homeworks. And hopefully you understood what the reading assignment said about inits. But anyway, you need to call super init before you can do stuff. So I'm going to then add a child behavior, which is gravity. And I'm going to add a child behavior, which is the collider. Okay, so this is how you build these composites. You add children behavior. Okay, now another nice thing to do is to have a func add item. Okay, which takes an item, which would be a UI dynamic item. Okay, remember that UI view implements this protocol. This is a protocol. Okay, UI view implements it. And here I just want to make sure that I add this item to all of my my children, basically, behaviors. So let's do that. And collider, Okay, and similarly, we don't need it for this demo, but to be complete, we probably want a remove item as well. Okay, so now we've created this new behavior that we can add items to, and this behavior can be added to an animator to cause this group of behavior to happen. So now let's go back to our drop it view, and instead of having these individual behaviors, let's create a new behavior. We'll call it drop behavior, which is a falling object behavior. Okay, so this is one behavior that encapsulates all those behaviors. So now we can put that instead of all these details. Okay, same thing down here. All right, so see how this code has gotten so simple now it fits on one page to do this, and the actual behavior, the dynamic behavior, is now encapsulated over here in this falling object behavior instead. All right. Okay, let's run this and make sure we haven't broken anything by doing that. Okay, I haven't really changed anything. I've just moved the code, for a different encapsulation. Here it is. We click. Hopefully these things will still hit the bottom. They do. Okay, so all is well. Now they're still can be tippy. Oh, see there, they're starting to tip. Oh no, they're tipping out. Okay, so they're still tipping, so we need to fix the tippiness. But now we're going to fix this tippiness here in our falling object behavior. And we're going to do that by adding another behavior. Okay, this is going to be the item behavior. This is going to describe how each of these items behaves when it goes in all the other behaviors. And we do that with a UI dynamic item behavior. Okay, and I'm going to initialize this in the same way that I did here, okay, with a closure. So let's let dib, dynamic item behavior, equal a UI dynamic item behavior. And now we can set all kinds of things that this dib, UI dynamic item behavior, knows how to do. For example, allows rotation? No. So now our blocks won't rotate. We could also do something like friction and also elasticity. So I'm going to do elasticity of 0.75. Elasticity of 1 is perfect elasticity. In other words, no energy is lost by the collision. They bounce off each other. So 0.75, there's a little energy lost, but so I'm not sure what the default elasticity is, but it was low because those things came down to the bottom and they didn't bounce much. They kind of just sat there. So I'll do that, and now let's return dib. And of course, we need to do the same thing here. Add this child behavior, our item behavior, and same thing here. We want to be able to add items to this, and we want to be able to remove items as well. Okay, so we've just added this behavior now. These things are all going to have this kind of behavior as they bounce and affected by gravity and things like that. And notice that to add this stuff, we didn't touch drop it view. Drop it view has not changed. Okay, we didn't change anything there. We're only changing this in this custom behavior that we built. Okay, so let's go ahead and run, see what those changes did, what having no rotation and elasticity did. So here comes our things. So here we go. Oh, look, they're much bouncier. And notice how they'll bounce into each other. Okay, they behave like real objects in the real world. They're bouncing, and they're not rotating, so they're not tipping over anymore. They're still bouncing up and down, though. See, when something lands on a row, it causes them to bounce up a little bit. But now we're on track for Tetris because now we're getting completed rows that we can have them have the rows removed. Now, for the code for removing a row, it's a little tedious for a demo here. I'm really just going to go across the row and do what's called a hit test in UI view. It has a hit test, which basically I'm just looking to see if there's a view there. So I'm going to go all the way across each row looking to see if there's a view. And if there's a view in every single spot, then I'm going to assume that row is complete, and I'm going to remove all those views. Okay, so I wrote that code outside. Let's go take a look at it. We'll put it, let's put it right here. Okay, it's called remove completed row. It's just this one method right here. Okay, you can see it goes through. It's doing this hit testing. It's trying to find the drops to remove. If it finds a whole row, then it goes through each of the drops and the drops to remove, and look what it does. It removes it from the drop behavior and then removes it from SuperView. So it just takes that drop out of there. Okay, so we're just literally just throwing it away. Okay, now the question is, when do we call remove completed row? Okay, do we just kind of call it randomly with an NS timer or something? No, we're going to call remove completed row when all the bouncing stops. Okay? When our dynamic animation engine pauses, then we're going to try and remove a row. Because if things are still bouncing, can't really be removing rows while things are still bouncing. So when things settle down, then we'll try and remove a completed row if we can. So if you remember from lecture, how do we find out that things have stopped? We use a dynamic animator's delegate. The dynamic animator will tell its delegate when things have paused, when things have reached stasis. Okay? So we're going to have to do the same trick here that we did with these other ones and use a closure to create this because we need to set the delegate of it. So let's go here. We'll create a little let animator equal this thing. And we're just going to set the animator's delegate to self and return animator. Okay, and we can use self in here because this is lazy, okay? Right, can we do that? But there's an error here. What's this error? Can't assign a drop-it view to UI dynamic animator delegate. So we need to go here and say that we are a UI dynamic animator delegate. Okay, say we implement this protocol. Now they're all optional, so we don't have to actually implement any. There's no errors here. But the one we want is that it will pause. And that, we'll just start typing dynamic animator, and you can see it's actually the very first one. Here's resume and here's pause. So let's go ahead and do the pause. So this gets called whenever everything reaches stasis, and I'm just going to remove completed row. If there are no completed rows, remove completed row does nothing. It only removes completed rows if there are some. Okay, so let's try it, see if it works. Could it really be that easy? Yes. All right, here we go. Drop some down here. Okay, we'll let it reach stasis where there's no completed row. Okay, nothing removed. Okay, let's add a whole bunch more. Let's add enough so that something becomes complete here. Okay, oops, nope, still need one more. This column right here, so we'll keep clicking until we get something in that column. There it is. Okay, here we go. Cross your fingers. Boom. Now, notice that when I removed those views, the animator leapt into action again because it noticed, whoa, gravity can now work on these ones that are not blocked by the other ones. Okay? And same thing here, and this will happen repeatedly. Yeah, question?
Yeah, so the last row, so sometimes the bottom squares are like a little bit off the ground. What's going on there?
Yeah, you see a little bit of white in there. Yeah. I'm not 100% sure what that is, but I think it's just an artifact that all this animation stuff is happening in CG float space, right? It's not happening on integer boundaries. And so it might be that these things landing, maybe they're 0.01, and so it's up enough, rounding up so that it shows the 1 pixel there. I'm not really 100% sure why it's not exactly on there. Remember that, you know, the physics, you got a lot of things bouncing here off of each other, different amounts and stuff like that. And these things, and when they could rotate, you saw they started tipping over even and nicking into each other. So this stuff is not all happening on integer boundaries. I think that's the bottom line of that. But I'm not 100% certain of that. All right, so anyway, this is working great. Okay, we got our Tetris engine really ready to go here if we just made these not be squares. And I don't have time to make them be actual, you know, L shapes and all that stuff. But you get the idea. Okay, and you understand how this works. So I'm going to, let's turn the rotation back on, because I want to show you something kind of fun here. Let's make the rotation be true again, and run. Okay, so we put it in here, and these things are going to bounce off each other. Oh, no, oh, no, no. But let's see if remove completed row can work here, because actually some of these rows still might have a view in every slot. Let's see. There we go. Remove that row. So it doesn't work quite as well, but it can kind of work. There we go. Okay? All right. What's next? Next, I'm going to make it so that, just to show you how the collisions work, because we only have collisions with the edges, I'm going to put a little round thing in the middle, okay, that these squares are going to collide against. Just a little round circle. So the squares are going to come down and boom, bounce off of it, because it's going to be this little round boundary, okay? Because you can put, with the collision behavior, you can put any arbitrary Bezier path as a boundary anywhere. And when you're doing your breakout game, you know, you're probably going to use those boundaries for the bricks, for example, okay, and maybe for your paddle even. You'll be moving the boundary constantly. Because the bricks and the paddle, they don't go flying around. When you hit them, they disappear or whatever. And the paddle, when you hit it, nothing happens to it. It stays perfectly the same. Okay, so let's go ahead and do that. We're just going to put a little round circle here that is a collision. So to do that, I'm going to go in my following object behavior here, and I'm going to make this. Unfortunately, my collider is private, and I'd actually like to keep it private in my little dynamic behavior here. But I am going to allow people to add a barrier. So I'm going to create a public function add barrier, and you can specify any path you want, a UI Bezier path that you want to be the barrier. And let's go ahead and you can name it as well. So we'll let you give it a name. And that's because when you put these barriers into the collider, you name them there as well. That's how you know which barrier got hit, okay, and which barrier you're going to add or remove or change. So this is all named, okay? And you just do that with a collider method add boundary with identifier. Okay, here it is. And so the identifier is the name, and the path is the path that was passed along in here. If someone calls this, by the way, I'm also going to conveniently remove any old boundary with that name. Okay, so if you call this repeatedly, it'll move the barrier around, just for convenience here. Okay, so this is a nice public function for adding a barrier. Let's use that in our drop it view to add a little barrier in the middle. Now, where do I want to put the code that adds that little thing? Well, I don't know where the middle of my bounds are until my bounds is set. So I certainly have to wait until my bounds are set. And actually my bounds could change, right? I could get rotated. Now my middle is a different place, and I want the barrier to always be in the middle. So you'll remember from our last demo that when a UI view's bounds change, what gets called? Layout subviews. Right? It doesn't have a view did layout subviews. It has the actual layout subviews that lays the subviews out. So that's a good place to put this thing in the middle, because layout subview is going to get called every single time the bounds change. So that's layout subviews. I'm just going to subclass that, super.layout subviews. And all I'm going to do here in layout subviews is to create a round path. So let path equal UI Bezier path. And there happens to be a Bezier path oval in rect thing to create them. And so let's have this rect be a CG rect whose center, this is one of my little UIKit extensions, is a CG rect that has a center initializer, will be bounds.mid. That's my midpoint of my bounds. That's also a little extension that I did there. And we'll have the size of it be the drop size. Okay, so we're going to put a little round circle, the same size as a drop, right in the middle. So we have that path. Let's just call on our drop behavior. We'll add this barrier with this path. We need to give it a name, so let's be good programmers here and do private struct path names, we'll call it. Static let. This one we'll call our middle barrier. And we can use any string we want here. It just has to be unique, so we'll call it middle barrier. Okay, so this is path names dot middle barrier. Okay, so I'm just adding this named barrier here to my collision behavior in my drop behavior. All right, so let's go try it and see what this looks like. All right, we're dropping them here. Oh, whoop! See that? If we drop one in the middle, right? Give me a middle one. There one. See, they're hitting off the middle. Now this is a little hard to see. You see that it's hitting the barrier, but you can't actually see the barrier. So how could we draw that barrier there? Well, we could implement drawRect, okay, our own drawRect, and draw it, okay, using just stroking the thing. But actually, I'm going to do something kind of fun. And this is really, I'm doing it this way to show you, always think object-oriented when you're building in iOS, okay? What I'm going to do instead to draw that little circle is I'm going to create a new UI view. Okay, a new UI view subclass, and all this UI view subclass I'm going to create does is it knows how to draw a Bezier path in itself. It's just a generic Bezier path drawing view, and I'm going to call it, what did I call it? Named Bezier paths view. Okay, because that's what it does. It's going to have a dictionary of Bezier paths, and it just draws them. It's really generic. It has nothing to do with drop it. I could well end up using this in some other app. Okay. And this is what this named Bezier paths view is going to have. It's going to have a public var called Bezier paths, okay, which is going to be a dictionary, which is string as the key, which is just an arbitrary name, and a UI Bezier path as the value. Okay? And that's public, and anybody who wants to use this can just add something to that, and when they do, I'm going to watch did set and do set needs display. Okay? So if anyone adds a Bezier path to this, then I'm going to needs display, and in my draw rect, I'm going to draw all these Bezier paths that are in this dictionary, which is super simple to do. Okay? I'm just going to say for underbar comma path, because I don't really care what the names of them are where I'm drawing them. That's only if someone who's using it wants to replace one that's already there, they can use the same name. In my Bezier path, so I'm just enumerating my Bezier path, keys and values, and I don't care about the keys. And I'm just going to say path.stroke. So here I've created the world's simplest little class, but it's a very powerful drawing class, okay? Because it draws arbitrary Bezier paths. Now, if I were really creating this, I'd probably maybe let you set the line width and color and other kinds of things. But here we're just going to do the bare bones of it here, okay? Now, how can I use this in my drop it? Anyone have an idea how I could really easily use this UI view to draw that circle in my drop it? How's about if we make drop it view inherit from it? Now all of a sudden drop it view has a new instance variable called Bezier paths, which it can set to any Bezier paths at once, and it'll be drawn in itself. Okay? Everyone got that? So let's do that. Okay? When we set this barrier, let's go ahead and set our own Bezier paths. Okay? This Bezier path is the dictionary that we inherited from that class we just created. And let's call it middle barrier again, path names dot middle barrier. Okay, we can give any name we want, and it's equal to that path we just created. Let's go take a look at this. And sure enough, there it is. Okay, now it's stroked with line width 1, black color, fine. But there it is. And if we drop things now, it's easier to see the things banging off of it. Okay? And this barrier, of course, if we pile up enough stuff, the things will start piling up around this barrier because everything bounces off of this barrier. It causes a collision. By the way, if we put something inside that barrier, okay, it would bounce around in the inside of the barrier. Okay? Got that? No remove completed row. Oh, okay, there we go. There we go. All right, so that's showing you a little bit there. Okay, the next one I'm going to do is an attachment behavior. So I'm going to allow myself, when a thing drops here, to grab onto a drop, okay, with my mouse or with my finger if it was on a device, and make an attachment to it. And remember, attachment is like an iron bar that hooks up from either a point to an item or between two items. In this case, it's going to be a point, the point my finger is. And what's also cool is, I'm going to do a pan gesture, and as my finger moves around, I'm going to keep moving that attachment point. And that bar is going to be dragged around with it, and the item too. Okay? So that's what we're going to do. Let's do that. Attachment behavior. So to do the attachment behavior, I certainly need an attachment behavior. So I'm going to create a private var, which is attachment, UI attachment behavior. Okay? Actually, we'll have it be an optional because we might not have an attachment yet. We don't have an attachment until we put our finger down on it to grab onto it. And when this attachment behavior gets set to something, we need to obviously add the behavior to our animator. Otherwise, this attachment won't do anything. Okay? So what do we need to do that? I'm just going to say if this attachment is not nil, okay, if someone has set the attachment to be something other than nil, then animator, add behavior, this attachment. Okay, everyone understand that? Now, one thing, by the way, I'm also going to do something we haven't done in a demo, which is will set. And will set happens before the new value gets set. And what do I want to do here? Here I want to say if my current attachment, before I've set it, is not nil, then I want to remove it. Okay, you see why I'm doing that? Right? If someone sets the attachment to something new, if there was an old attachment, I want to remove it. Okay? So here I'm just making sure that every time I set attachment, the old one gets removed, the new one gets added. All right? Got that? Okay, so we've got this attachment. How are we going to set this attachment? We've got to set it to something. I'm only going to allow you to grab onto the last drop that was dropped, okay, because you can drop a lot of drops. Only the last one you dropped can you grab onto with this pan gesture. So I'm going to need a var for the last drop. So let's go ahead and put a var, I don't know, we'll put it down here. Private var last drop, okay, which is a UI view. Okay, and it also could be nil. We might not have dropped anything yet. And every time we add a drop, I'm just going to set the last drop equal to the drop. Everyone understand there? That's just grabbing the last drop. So now I have the last drop, okay, and I get my finger down. I need to grab onto it, okay, and create this attachment behavior. So how am I going to do that? All right, let's go here and create a function called grab drop, which is going to be a pan gesture handler, okay? Because we're going to have a pan gesture be how we grab onto this falling drop, okay? So first, I'm just going to get the point of the gesture point. That's the recognizer location in view, or self. Okay, so now we know where that pan gesture is, either at the start or as we're moving it around, we know where it is. So now let's handle these pan gesture states, okay? Recognizer.state. If it's began, right, if this thing just began, then we need to, create the attachment. Okay, if it's changed, okay, the person moved the attachment around, now we need to change the attachment's anchor point. Okay, because remember I said the attachment is going to attach a point to that drop, and so as we pan around, we're going to keep moving the point that it's attached to, and that's going to drag the drop around with it by the iron bar, okay, by the stiff bar. Otherwise, I'm just going to set the attachment to nil, okay, because if it's not begin or change, then it's either ended or some failure or something like that. I want this attachment to go away. Okay, if there is an attachment, I want it to go away. So that's basically the end of the line if we do that. All right, this one's easy, okay? Create the attachment's anchor point. That's super easy. That's just attachment, if we have one, anchor point equals the gesture point. Okay, that's it. Okay, remember the attachment is just a behavior. It's an object. It's got a var on it, which is the anchor point. If it's a point connection to a item, it's got an anchor point. And we're just going to, as you drag around with the pan, we're just going to keep changing that. And the animation system is automatically going to react to that. We don't have to do anything. Just automatically it's going to notice that change and deal with it. How about creating the attachment? Well, here we better make sure we have a drop to attach to. So I'm going to say if the drop to attach to equals the last drop. Okay, so in other words, if we have a last drop, because we might have just started, and obviously if we start panning when there's nothing dropping, we can't do it. And I also want to make sure that that drop to attach to is in the view hierarchy. Okay, so I want to make sure it hasn't been removed from super view by remove completed row or something, or any other way. So if I got a drop now, I'm just going to create an attachment by saying it equals a UI attachment behavior. Oops, here we go. Attachment. UI attachment behavior. And you can see here's the different kinds of attachments you can create. Attached to an anchor, an item attached to another item. You can even attach items to anchors or other items offset from center. In other words, the attachment doesn't have to be in the center of the thing. It could be on a corner. If you do that, then as you pull it around, that thing's going to be spinning around. Because you got, if you have the corner of a rectangle and you pull on it, it's going to rotate as long as you allow rotation. Okay, but here I want attached to anchor, obviously. I'm going to attach it to the anchor, which is the pan. The item is the drop to attach to. And the anchor is the gesture point. Okay, where the pan gesture went on. By the way, I'm going to make my game so that once you grab onto this thing, you can't grab onto it again. If you drag on and let it go, you can't grab it again. So I'm going to set last drop to nil in the case where I create an attachment. Okay, we have to obviously add the gesture recognizer that calls this handler. So we were going to do that obviously in our controller. Okay, just like we added this tap gesture. Let's go game view.add gesture recognizer, UI pan gesture this time. The target this time is the game view, okay? And the action is a selector, which is the drop it view, grab, drop with an argument. Okay? Everybody got that? All right, we'll go back here so you can see this code on the screen at the same time. Let's run that. All right, here, so we drop it. I didn't grab it, okay? I'm going to drop another one. I grabbed it. Okay, do you see what's happening? It's kind of hard to see. Watch this. Boing. Okay, so this thing is bouncing around. I'm dragging it around, okay, with my finger. Look, I can even bounce it on the iron bar. Woo! Now, it's kind of hard to see this. Wouldn't it be cool if we could draw a line there, okay, so that we could see this iron bar that this attachment behavior is creating? And of course we can do that because we inherit from a class that knows how to draw arbitrary Bezier paths. So just like we drew this little one, let's draw that bar. But it's a little tricky because that bar is always changing. As I drag it around with the pan, right, that thing is always changing. So how are we going to have a hook to know when to draw it? And this is where that really cool UI dynamic behavior mechanism I was talking about is action, right? Action is a closure that you can set that will get called every time that behavior acts. Perfect. So I'm going to put that behavior on that attachment so that every time that attachment has any effect on something, I'm going to redraw my line. Okay? Perfect opportunity to do that. All right. So how am I going to do that? Where's a good place to put that? Let's put it down in when we create the attachment, I guess. Where is that? Here it is. Okay, here's where we create the attachment. Okay, this is where we're adding the behavior. So I'm also, in addition to adding the behavior here, I'm going to say the attachment, I have trouble typing that. The attachment action equals some closure. So in here, this is where we want to draw that line. Okay, so how are we going to draw this line in here? How about let's get the attached drop, okay, because I want to draw a line between the point, okay, that the gesture's at and where the attached drop is. So I need to find that attached drop. So how can I find the attached drop from the attachment? Well, here's how we would do that. We can get the attachments, get the attachments items, okay, that's all the items that it's attaching. Now it's only going to be having this one drop attached, okay, it only attaches one drop. But so this is an array of items. So I'm going to get the first one out of there because I know there's only going to be one. So I've got this first thing, and I'm going to make sure it's a UI view. Okay, I just want to be 100% sure it's a UI view, and I want this var right here to be of type UI view. Here it's complaining because this is a closure, and so we have to have self, explicit self, because we're capturing self, which is actually going to be a huge problem here, by the way, to capture self. We'll talk about that in a second. All right, so now I've got the attached drop. I just need to create a Bezier path, okay? UI Bezier path. And I've got a nice line from, okay, UI Bezier path line from the attachments anchor point, not replacement, anchor point to the attached drop center. Okay? I'm doing there. Okay, we also need some self dot going on in here. We can do that because we know we're good on the attachment. What else we got here? Okay, and so we need to give this a name, right? Because the Bezier path is a dictionary, so we need to give it a name. So let's go back down here and create another named path. This one we'll call attachment. All right, so this is going to be our Bezier path sub path names dot attachment. Maybe for readability here, I'll put this on the next line. Okay, so there we've created the Bezier path to show this attachment. Everybody cool with that? Now the other thing is when we remove it, we better remove that thing. So self dot, we don't even need self here because we're not inside a closure. Bezier paths sub path names dot attachment equals nil. That's a way to remove something from a dictionary, by the way. Just set it to nil. Okay, pretty cool with that? Now, as I mentioned, we have a serious problem here with self being captured. okay? Because this cell, okay, this closure keeps self in the heap, and self keeps the closure in the heap because self-attachment action equals this closure. So they each have strong pointers to each other. They can never leave the heap. Now, this one we can fix with unowned self because we know that this behavior is going to leave the heap as soon as self leaves the heap. So it's perfectly safe here to say unowned self to break that loop. Okay, self will never be around when this attachment behavior is still around. Okay, so let's see if that works. All right, let's drop a few down. I'm going to grab the next one. There it is. Okay, so now we can see a lot better what we're doing here. So we balance it. Okay, got it. Make sense? All right. So that is all I wanted to show you for behaviors. Any questions about all that stuff? I showed you a lot of behaviors there: attachments, colliders, item behaviors, gravity. Okay, so that's plenty of stuff to help you get started on your homework there. All righty, let's go back and look at some slides here. So now I'm going to talk about Core Motion. Okay, Core Motion is an object-oriented API to get at the motion sensing hardware on your device. So that's accelerometer, the gyro, magnetometer, those kind of things. All right. Not all devices have all of this hardware, although in recent years they all do. But, you know, if your app wants to run back on iPhone 4 or something like that, it doesn't have a gyro, for example, so we kind of have, for good programming technique, want to check to make sure that we have the hardware, and you'll see that in a second. You get at all this stuff via an instance of CM Motion Manager. Now, you really only want to have one CM Motion Manager in your entire app because there's only one gyro in your entire device, right? So it really makes no sense to have two motion managers trying to, you know, cross over each other. You need to coordinate it. So if you really had two different places in your app where you were accessing this hardware, then you would need to have a shared motion manager, either as a static on some class somewhere, or maybe part of your app delegate or something like that, that is, you know, dealing with the fact that two different people want to look at the hardware at the same time. Okay? So how do you use this motion manager to get this information? Well, first, there's two ways really. Okay, one way is by polling, and one way is by getting constant updates about what's going on. Okay, but in either case, first you're going to check to see if the hardware is available, and I'll talk about how you do that. In the polling case, you're then going to tell the motion manager, okay, I want accelerometer updates. Okay, and that'll turn that on, and then you just ask it, what's the current accelerometer? What's the current accelerometer? Anytime you can ask it you want. You're polling it, basically asking it. So that's one way. Rare that you would do it that way. The second way, again, you check to see the hardware is available. Then you're going to set the rate at which you want the system to tell you about accelerometer or gyro or magnetometer updates. Okay, so 5 times a second, 30 times a second, probably not much more than that. I mean, you can only draw at maybe 60 frames a second, so you know, you're probably not going to need the information much more than that, but you're going to tell how often you want it. Okay, then you're going to give it a closure, okay, a block of code, and it's going to execute that closure that many times, 5 times a second, 30 times a second. And that closure, the arguments to it are the current state of the accelerometer or the current state of the gyro. Okay, so those are the two ways to do it. So let's see how all this works. Checking the availability, you just ask the CM Motion Manager, accelerometer available. That's a bool. Okay, and it'll tell you yes or no, or magnetometer available, and that's how you find out. Okay, so it's as simple as that. So you always want to check that though, because if it's not available and you start asking for things, you're going to get errors. All right. Now, how do you, if you're doing the polling case, how do you start this thing up? You just say start accelerometer updates, start gyro updates, and it'll start looking at that hardware. Now, this is not free. Okay, having this thing start listening to these pieces of hardware costs battery especially, okay, and some CPU too, but it costs battery. So don't turn this on unless you're really ready to start getting the information. Okay, you can ask the CM Motion Manager whether it is currently has that hardware fired up, basically, by saying, you know, accelerometer active, and that's a bool, yes or no. By the way, you notice in all here, you see accelerometer, gyro, magnetometer. You also see this thing device motion. Okay, device motion is kind of a special device. It's really a combination of the other three. okay, an intelligent combination of the other three. And we'll talk about that in a moment here. And then to stop the hardware, to turn off the accelerometer, turn off the gyro, you just say stop whatever updates, okay, and that'll stop it. And you want to do this as soon as you realize I don't need it. Even if you only don't need it for a little while and you're going to go back and turn it back on, fine. But anytime you don't need it, turn it off. Okay, don't waste the user's battery by having this thing working when you're not actually using the data. Okay, so that's how you kind of control the hardware. Now, again, we're talking about polling here. How do I then say, okay, well, you got the accelerometer turned on. What is the current value of the accelerometer? And you just use this CM Motion Manager var accelerometer data, and it gives you this struct, CM acceleration data, accelerometer data struct, and it's got the acceleration in X, Y, and Z. Okay, so what is this X, Y, and Z? So here I have a device. Okay, so Y, okay, Y is this axis right here, pointing down through the home button. Okay, so this is the Y. Okay, it's this vertical axis. Okay, X is perpendicular to that. Cross the device this way. So this is Y with the home button being down, and this is X. Z is out the back. Okay, so if I put this on a table, Z, what do you think Z value would be? 1.0. Okay, why 1.0? Because X, Y, and Z here are in G. Everyone know what G is, right? 9.8 meters per second squared. That's what G is. So Z would be 1G if I sit it right there. Okay, because the acceleration due to gravity is operating on it. And it does tell you the acceleration due to gravity, in addition to the acceleration due to the user moving the thing around. Okay, acceleration going all over the place. Okay, but the acceleration due to gravity also counts. So that would be X and Y 0, Z 1.0. Similarly, if I do this, this would be Y 1.0, X and Z 0. Okay, so that's the acceleration there. You get similar information for gyro. Okay, the gyro is the rotation of the device. Okay, how it's rotating. Okay, and this is going to tell you this in radians per second, same axes. Okay, radians per second, how this thing is rotating. Now, there's a bias in here. I don't know if people know what a gyro bias is, but one simple way to think about it is, if I'm moving like this, what if I'm also moving like this? Okay, you can see how that might make the gyro think this is moving faster than it is because it's moving this way in addition to this. So there's a bias in there, and also just the gyro equipment has a bias built into it. Now I'm going to show you in a second a way to get this rotation as pure rotation without that bias. Okay, and also a way to get the accelerometer data without gravity. The magnetometer is measuring magnetic field, right? This is the thing that you can find true north. You can basically find out which way each of those axes is pointing relative to true north by measuring the magnetic field around your device. Okay? Now, I talked about the bias and acceleration due to gravity. Here's how you get that out of there. Instead of using CM accelerometer, okay, or CM gyro, you use this device, CM device motion. And that's the one that's the combination of the other three. And by combining them and using the data from all of them, it can tell you the part of the acceleration that is gravity and the part of it is the user moving it. Okay, because it has the gyro, you see? So it knows from the gyro what's going on there. Similar, because it has the accelerometer, it can unbias the gyro. And it reports to the gyro to you like an airplane. Any of you pilots, anybody involved in piloting know about it? Okay, so imagine my iPad here is an airplane. Okay, the way an airplane describes its motion is it has roll. Roll is this. Okay, this axis in the middle, how you're rolling. Okay, this is roll. So when airplanes turn, they roll, and that causes them to turn. Okay, then there's pitch. That's up and down, right? Airplane climbing and descending. Okay, and then there's yaw. Yaw is when an airplane, let's say there's a fierce wind coming this way. The airplane wants to go that way, but it actually has to turn this way to fight this wind. Okay, the amount it's turned along this axis is the yaw. Okay, so you got roll, pitch, and yaw. Okay, so that's what we reported to you with CM device motion, and that is independent of any motion, whether the airplane is going fast or sitting still, whatever, you're going to get that roll, pitch, and yaw. Okay? So that's device motion. Really powerful mechanism. If you're doing anything with the gyro, you're probably going to be using device motion instead of CM gyro. Okay, magnetic field. With the CM device motion, it can tell you the accuracy of the magnetic field. Okay? All right, so that we talked about how to poll. You just ask for the information you want. How about if you want to be notified 5 times a second or 30 times a second of what's going on? Very easy. You just call start accelerometer updates or start gyro updates or start device motion updates to queue. And you give it a queue. This is not a dispatch underbar QT. This is an NS operation queue, the object-oriented version I talked about. But probably you're going to be passing NS operation main queue, or maybe you'll use NS operation current queue if you're on a different queue. You don't really want to do this on the main queue if you're going to be doing it at a very high rate, like 30 frames a second, 30 calls a second. Unless you're doing something really simple, just think about it. You don't want the main queue busy doing that. But if you're doing 4 or 5 frames a second, oh, absolutely. And doing something simple, you can do that. Then you give it a handler. This is just a block, a closure. And you can see that closure has 2 arguments. One is that same CM accelerometer data we saw from before, the X, Y, and Z in G, that thing. Okay? And also an error, possibly. Okay? These are optionals. Probably if one's nil, the other one's not, vice versa. Okay? So this is just closure. And inside that closure, you can do anything you want with the accelerometer data. All right? Similar with the gyro. Start gyro updates to queue. You're going to get the gyro data. Start magnetometer updates to queue. You're going to get the magnetometer data. And, of course, start device motion updates to queue. Okay? And you get the CM device motion. That's that thing that has vars like gravity and attitude for the roll, pitch, and yaw, that kind of stuff. Just to talk a little bit about the errors, you're of course going to want to look in the documentation, but some of the errors you can get are like it can't find true north, maybe too much interference, maybe this activity is not authorized, okay? Maybe the user, you're not authorized to actually measure the device's motion, okay? That could be too. So you do want to be able to check for these errors to make sure you're actually getting good data. All right, so how often you get these closures called is set with these vars in Motion Manager. Okay, the update interval. This is just the number of seconds between calls. So like 0.25 would be 4 times a second. Okay, it is okay to have multiple closures registered. You can say start accelerometer updates with handler and then call it again with another handler. But understand they're all going to be called at the same interval because there's only this one Motion Manager that you're going to create for your whole app. Okay. All right, so let's take a look at this. Let's take drop it, and let's make the gravity that's in drop it be real gravity. Okay? Right now the gravity just goes down towards the home button, but let's make it so that it's actual gravity. So as I move my thing around, those blocks are going to start swinging towards real gravity. All right. So how are we going to do that? I'm going to go to my drop it view right here. I'm going to add a new var, public var, called real gravity. And it's going to be a bool. Okay, I'll start it out being false. And if this is on, then I'm going to use real gravity in my drop it. If it's off, I'm going to use fake gravity, the gravity I already have, basically. All right? And so let's go back to our controller and set this to be true. So I'm just going to do it here in the did set here. Game view.real gravity. Real gravity equals true. Okay, so we got real gravity turned on. And how am I going to make this real gravity work? Well, anytime someone changes this, I'm going to call some method update real gravity or something. And this is the method that's going to have to turn the accelerometer on and start using it. Okay, so that's a private func update real gravity. Okay, so this is going to be the guts. This is going to be the thing that's actually doing the work here. All right, so what is update real gravity going to do? Well, it's going to do something with the accelerometer. I'm going to use the accelerometer to get the gravity. I'm not going to use device motion, okay? Just to make it simple, we're using the accelerometer. We want the real gravity anyway, so we'll use that. So I need a private var here, which is that motion manager, because I told you need a motion manager to do any of this. So we'll just say that equals CM motion manager. I'm not using any of this in any other part of my app, so I'm putting it here. Again, if I was using it in 2 different places, I'd have to make this be some sort of shared resource. Notice it's complaining right here, okay? It's never heard of CM Motion Manager, doesn't know what the heck we're talking about. That's because this is in a different framework. Import core motion. Okay? All this core motion stuff, you have to import core motion. All right? So we have our motion manager right here. How are we going to use our motion manager to grab that accelerometer information? So if we want real gravity, then we're going to do that. By the way, if we don't want real gravity, then I'm going to tell the motion manager to stop accelerometer updates. Again, I always want to stop that updating happening anytime I don't want the updates, okay? So try to keep that off as much as possible. But if we do want real gravity, then first I'm going to check to see if the motion manager accelerometer is available. Okay, as promised, this is first thing we need to do. Actually, I'm also going to see here if the accelerometer is already active, because maybe I already called update real gravity and it's already running. So I'm going to actually say, and the motion manager accelerometer active is false. Okay? So if the accelerometer is available and it's not already running, then I need to fire this thing up. Okay? So let's fire it up. Let's start with our update interval. So I'm going to have the accelerometer update interval be maybe 0.25, 0.2 is probably enough. You know, gravity doesn't really need to change that much more often than that as I'm moving my device around. It's a number I could play with. Again, this should definitely be a constant, but we're time constrained here, so I'm not going to do that. So now I'm just going to have the motion manager start giving me update to Q. Okay, so this is how I started updating. Now what Q am I going to use? I'm going to use the main Q here because I'm only doing it 4 times a second, and I'm only just going to set that gravity thing. That's all I'm going to do. So that's really lightweight. So I can just use the main Q. So enter operation Q main Q. Okay, here's the handler, the CM handler. I always recommend double clicking on these things because it fills out really nicely your arguments and stuff like that. I'm also going to use the closing or the trailing closure syntax here to do this. All right, so I'm going to start the accelerometer. Here is my closure that I have to do. Okay, so this accelerometer data, I'll call it data. This error, I'll call error. Okay, so how am I going to do this? Well, this data might be nil. This is an optional. So I'm going to see if I can get the accelerometer data first. So let's say if I can let we'll call the x, I'm only caring about x and y, don't care about z, okay, because I'm going to have the, my little drop it is 2-dimensional, so it doesn't care about z. So if I can let dx equal the data acceleration in x, and also we can let dy equal the data's acceleration in y. So there I'm just simultaneously getting and checking to be sure the data is not nil. So I've got the dx and dy. Let's first try to just set the drop behavior's gravity direction to just be a CG vector, which is dx and dy. Okay, so we're going to try this first. Now, this is not going to work because gravity is private. So let's just go over to our behavior, following object behavior here. I'm going to make this not be private. Okay, just for expediency. Maybe we want to make some other public API like we did with the collider here. But I'm just going to make this public, make it a little, go a little faster. All right, so here we are. We're setting this gravity here. Oh, yeah, good one. That's it. Okay, got it. Very good catch. Bonus points. All right, so there's that. One other thing I want to be careful of here is memory cycle. Okay, I've got this accelerometer. Okay, this motion manager has an accelerometer. That thing has a hold of this closure. I have a hold of it. Okay, I have a hold of the motion manager. The motion manager has a hold of me. Okay, so that's not good. Again, we can do unowned to solve this one. Oops, I'm going to put it there. Unowned goes over here. We can do unowned self here because as soon as self leaves the heap, this motion manager is going to leave the heap with it, which means this closure is going to go out too. So this closure will never get executed with self not in the heap. Once self leaves the heap, this guy goes with it. So we can do unowned here to do that. The only other thing I want to do here is if I want to try and turn this accelerometer updates off as much as possible. So another time I want to turn it off is if I'm not animating, right? If I have my drop behavior, okay, and it's not currently animating, I do not want to be continuing to do this. So I'm going to say only do this if my drop behavior, its dynamic animator, is not nil. That's how you can tell whether a behavior is currently being animated. If it has a dynamic animator, it's being animated. If not, it's not. So if it's not nil, then we'll do this. Otherwise, I'm going to stop this motion manager. Okay, stop accelerometer updates in this motion manager. You see how I'm trying to stop this thing as much as possible? The only thing about this, though, is if I do stop it because I stop animating, then I better be sure that when I start animating up again, remember this is that animating var, and you set it to true to start animating, I better update my real gravity here to make sure that I start the accelerometer back up again. Okay? So that allows me to start and stop animating. It stops the accelerometers. Every time I restart it, it starts them again. Okay? So let's try this and see if it works. Now, this is the first time in this class where I'm having to actually, I can't do it in a simulator because the simulator has no accelerometer or anything like that. So we're going to be doing it here on this other device. So let me run over here and show you this. All right, so let's run this on our device here. Here we go. It's coming up here. There it is. We see our little circle. If I tap, oh, it's not working. What's going on here? Why wouldn't that be working? I got the gravity going on there. Maybe if I turn my thing upside down. Oh, whoa! That worked. I turned my iPad upside down and all of a sudden gravity seems to be backwards here. Okay, now why would gravity be backwards? The answer is because our drawing coordinate system has 0, 0 in the upper left. So this is working fine. It's falling down towards 0. It's just that's in the upper left. So we need to add some code here that knows what the orientation of our device is and adjusts, okay, for the fact that it's upside down, basically. Also, when we turn sideways and we're looking at landscape mode, we want to make sure that's doing the right thing as well. So let's put that in here. Okay, that goes right. So let's put that right in here. Okay, we've got our dx and dy. All I'm going to do here is I'm going to switch on my devices. This is how you get the current device's orientation. Okay, this will return the orientation of the current device. And so, for example, in the case of portrait, okay, we know that portrait is upside down. So I'm going to say dy equals minus dy in portrait. In the case of portrait upside down, everything's fine. We know that that works. Okay, portrait upside down, I got the right thing. How about landscape left, or landscape right, let's say. In landscape right, x and y are swapped, right? Because I've turned it sideways. So now it's the x of my device that's down. So I need to swap them. There's actually a nice method here, or function called swap, which will swap two variables. Okay? And then in landscape right, left, not only are they swapped, but also dy has to be minus dy. Okay? In other cases, there are other cases like face up and face down. Those are orientations. In those cases, there should be no gravity going on. So I'm going to say dx equals 0, dy equals 0. Okay? Because my thing is flat or whatever. Now, notice I'm modifying dy and dx in here, but I said if let. Just remind you all, you can change this to var. If var. Exactly the same as if let, it's just that these will now be vars that inside here you can modify. Okay? Everybody got that? Okay, so let's try that. All right, here we go. Drop it. Oh, it's working. Look at this. Okay, dropping some more things. I have my thing face up. Okay, now I'm going to turn my thing upside down. Let's see if they all fall down. And they do. Excellent. Okay, now I'm going to turn it sideways. Bam. Okay, sideways around the other way. Okay. Now, one thing that's interesting about this is I actually have my rotation locked. If I unlock my rotation, then my view is going to change. Watch this. See? So since it switched, all the views moved to the bottom. So it didn't actually do much. Now I can try and move it around without changing my orientation, but as soon as my orientation changes, it's going to jump around. Got that? Okay. All right. That's it for today. You have everything you need to know, I hope, to do your assignment 6. If you have any questions, I'll be here as usual.
For more, please visit us at stanford.edu.